Okay, I have a radical inside a radical, so what I can do is I can combine that all into one. My square root is an unwritten index of 2. So when I combine these into a single radical, I'm going to take the product of their indices. So 3 times 2 is 6. And I get 27 a to the 6th b cubed. And now, here's one of the things that kind of makes this tricky. Hey, what do you notice about 27? Yeah, it's a perfect power, right? You have, you can think of it in terms of factors, but in this case, you can also think of it as just the exponential form of 3 cubed, a to the 6th, and b cubed. So what can happen in this particular case is we can simplify, right? We can reduce our index. The index and powers can't have any common factors. So you either have to cancel common factors between all factors, powers, and the index, or you can kind of think of it in terms of this. If you can rewrite this as some quantity cubed, right? You have 3 cubed. You have what can you cube to get a to the 6th? So you have a squared cubed, and then you have b cubed. Does everybody see how I kind of rewrote this as one group of cubes rather than individual factors? What you can now do is cancel. The 3 goes into 3 once, 3 goes into 6 twice. And so you wind up with the square root of 3a squared b. Is this simplified yet? No. How many groups of 2 can you remove from the 3? Or in this case, the 3 stays inside the radical. How many groups of 2 can you remove from the a's? That comes out with none left in the radical. And how many groups of 3 or 2 can you remove from the b's? None. So that stays inside. And now we're still not done. Our original index was an even number. So when we look back here at the a, can a be a negative in our original form? Yes. So when we test it here, if a is a negative, will this guarantee to never be a negative value? Not without the absolute values. Now, when we look at b, can b be a negative in the original form? No, so we don't even need to worry about b. This would be our solution. Bella? I move this into the blue step. All right, so the other alternative, if you don't see what I did in the blue step, is from here you could have also gone this direction. If every base factor that you have in your problem has a common factor, you can cancel that with your index. So what goes into 6, 3, 6, and 3? 3, right? So 3 goes into 3 once, 3 goes into 6 twice, 3 goes into 3 once, 3 goes into 6 twice. And so that's going to get you right down to this form as well. Okay, so you can do it individually, but you do need to be able to see 27 is a perfect power and think of it in that exponential form with the smaller base, 3 cubed.